Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry Quarter 2's performance task. To begin with, it would be good to refresh yourself with the properties of quadrilaterals. This will really help you with several of the questions in the performance task. So, parallelograms have both pairs of opposite sides being parallel, and those opposite sides are congruent. The opposite angles are also congruent, and then consecutive angles are supplementary, and the diagonals bisect each other. A rhombus has all of the same properties of a parallelogram, but it also has all four sides being congruent, and their diagonals are perpendicular, and they also bisect the angles. Rectangles also have all the properties of parallelograms, but all of the angles are congruent right angles, and their diagonals are also congruent. A square is a parallelogram, it's a rhombus, and it's a rectangle, so it has all of those same exact properties. A kite has no pairs of opposite sides being parallel or congruent, but each pair of adjacent sides are congruent, and then one pair of opposite angles are congruent. Their diagonals are perpendicular, and one diagonal bisects a pair of opposite angles, and one diagonal bisects the other diagonal. A trapezoid just has one pair of parallel sides, but an isosceles trapezoid has that same one pair of parallel sides. Their non-parallel sides are congruent. Both sets of base angles are congruent. Their diagonals are congruent. One angle from each base is supplementary, and opposite angles are supplementary. All right, for our next question, it would be helpful to utilize the distance formula in order to find the length of a different segment. So on your performance task, they are going to give you coordinates, and you're going to use those coordinates and plug them into the distance formula like this. And that's what we get when we plug them in, and now we simplify to solve. When you simplify, you actually get that the distance between these 2 points is approximately 14.9. And you'll have to do that for the other shapes as well. You have 3 shapes you need to do the distance formula for, and then you'll need to add all of those shapes together to get your total distance for that part of the hike. Another question that you're going to have to go over uses the trapezoid mid-segment theorem. So it's important to remember that the mid-segment of a trapezoid is simply the 2 bases added together and then multiplied by a half or divided by 2, because multiplying by a half and dividing by 2 are the same thing. So they give you 2 bases, and all you have to do is add them together and divide by 2. So the mid-segment of this trapezoid would be 21.5 feet. It will also be wonderful to know about right triangle congruence by SAS. Remember that SAS means side, angle, side. So here we have 2 right triangles, and because both of these are right angles here and here, that's the angle part already found. We have an angle. So we will need to find the 2 sides that go around that angle. So this angle is formed by these 2 legs here in the yellow, and these 2 legs here in the yellow. So if you can prove that those 2 legs in the yellow are congruent to each other, you have congruence by side, angle, side. Your textbook describes a polygon as a closed figure with at least 3 sides that are segments. The sides intersect only at their endpoints, and no adjacent sides are collinear. So what that means is that you have to have at least 3 segments. This would not be a polygon because it's not closed. If we were to close it with a 4th line, it would become a polygon. If we were to do the same thing here, like this, and then cross like that, that would not be a polygon anymore because the sides do not intersect only at their endpoints. They intersect here. Don't forget to upload any of your work that you have here as well. It's worth a lot of points to do that. Good luck, everybody. I hope you guys do great.